Okay, so starting at the beginning with this practice that I asked you to do. Sorry, I'm looking for something and I can't find it. I want to talk about nitrogen and hydrogen reacting to give ammonia. Now, nitrogen is N, but it's one of those things that appears as a diatom. So it's going to be N2. He happens to appear as a gas naturally. So he's N2 gas. Hydrogen, H. He is one of the naturally occurring diatoms, so he's H2. He also appears as a gas. They react and they give me ammonia. Now, ammonia is one of those things that's got a common name. So he's in my common names table. It's down here somewhere. Common names. Ammonia is NH3. I can put NH3. I happen to know that NH3 is a liquid. Household ammonia is something I clean with, so NH3 is where I can find that. Now, if I want to balance this, I know that I have nitrogen and hydrogen on both sides of my equation. I have 2 nitrogen and 2 hydrogen on my reactant side. I have 1 nitrogen and 3 hydrogen on my product side. So clearly I am not currently balanced. So how am I going to fix this? Well, I could start pretty much anywhere. I know that I need 2 on this side to get 2 nitrogens. So I've fixed that. Now I've got 6 hydrogens on my side, right? So I have 2 nitrogens, so that's fine. I now have 6 hydrogens on this side. So I can put a 3 out here, and that changes that to 6. And look, magically, everything is now fixed. Oh my God, that's so much fun. So I can leave that, and everything is good. Cool. Okay. Water decomposes into hydrogen and oxygen. Now, water, I happen to remember, is H2O. Water is a liquid, so when we have it as a gas, it's steam. When we have it as solid, it's ice. So water decomposes into hydrogen, H2 gas, and oxygen, O2 gas. Now, I'm assuming that it's in gas form when it's decomposing. Could be either. I mean, it really doesn't matter. Again, it's not important that I know which phase it is right now. I'm just trying to develop that habit for myself. Okay, so I have hydrogen and oxygen that I need to deal with. Currently, I have 2 hydrogen on my reactant side and 1 oxygen on my reactant side. I have 2 hydrogen on my product side and 1 oxygen on my 2 oxygen on my product side. So my oxygen is a problem. Knowing that I have 2 over here, I'm going to multiply this one by 2, and that will change that to a 2. But now I've also screwed up the hydrogen, so now that becomes a 4. And if I've got 4, now I need to change this one from 2 to 4. So I put a 2 out here, that changes that to 4, and now everybody is happy. So that's actually how I accomplished that when I was doing it before, and I didn't explain to you how I got there. That's how I did that. Cool with that. All right. This next one says methane and oxygen. Well, okay. I don't know what methane is, but let's go see if he happens to be in this table. He's not. So how the heck am I supposed to figure out what methane is? That's a good question. If he's not in this table, I'm not really sure how I'm supposed to know what he looks like. So I can look a couple of other places and see if I can find him. Let's see, benzene, ethanol, hexane, pentane, toluene, water, acetic acid, carboxylic, or cyclohexane. Don't find him in there. I don't happen to see him anywhere. So that's rude. How am I supposed to know what he looks like if I didn't tell you anywhere what he was? You honestly can't. But since this is just a thing, and I'm supposed to be available to you while you're doing this, I could tell you that methane is CH4. It's usually a liquid, so I can tell you that too. Now, that can react with oxygen. Oxygen is O2 gas. And it gives carbon dioxide, CO2, normally a gas, and H2O, usually a liquid. So I've got carbon, hydrogen, and oxygen that I need to deal with. I currently have 1 carbon on my reactant side, 4 hydrogen on my reactant side, and 2 oxygen on my reactant side. I have 1 carbon on my product side. I currently have 3 oxygen and 2 hydrogen. Clearly, I am not balanced. Okay. So I know I have the same number of carbons on both sides, so I'm going to try not to affect my carbon. But I know that I need to deal with my hydrogen, and I have 4 over here and only 2 over here, so I'm going to try to multiply that by 2. The other reasoning that I have is that I would like to get an even number of oxygens because I have an O2 on the other side, so I'd like to make them be an even number. So this is now changed to 4, and I've changed the oxygens to +2, that's 4. So since I have O2, I can put a 2 in front of that, and that is now 4. And yay, everybody's happy. Cool with that. Awesome. Now, ethane is listed as C2H6. C2H6. And I'm not going to, at this point, put my physical state. So it reacts with oxygen, O2, to yield H2O and CO2. Now, you may look at this and go, wait, I had CO2 and H2O before. It's a fairly common thing. What we're talking about is that reaction with oxygen to give H2O and CO2 is very common. It's called a combustion reaction. So anytime I burn something in oxygen, this is what we're doing. So I was burning methane before, I'm burning ethane now. This is a fairly common thing that we do. So anytime you see water and carbon dioxide as products and oxygen as one of your reactants, it's probably a combustion reaction that you're looking at. Okay. Is it important that you know that? Not really, but sometimes it makes it easier to look to categorize it in my head. So carbon, hydrogen, oxygen, again, what I'm dealing with. Currently I have 2 carbons on my reactant side. I have 6 hydrogens and 2 oxygens. I currently have 2 hydrogens on my product side. I have 3 oxygens and 1 carbon. Clearly I have issues. Now my carbons aren't fixed, so I'm going to turn that into a 2. So that turns that into a 2. I now have 5 oxygens. That's not happy. I also have problems with my hydrogens. So since there are 6 over here and I have 2 over here, let's multiply this by 3. So if I do that, I now have 6 hydrogens. And I've got 6 hydrogens, 3 oxygens there, and now I have 4 here, that's 7 oxygens, right? So I've now got 7 oxygens on this side. And I've got 2 over here. My carbons are right, my hydrogens are right. I have 2 oxygens on this side, and I have 7 on this side. And you're like, oh my God, that's so close. What if I could do 7 over 2? And remember I said something about 7 over 2? This is what I was talking about. So this is one of those cases where if I could just put that there, then I'd be okay, right? So the 7 over 2 and the 2 here means that I would then have 7 oxygen. So that would give me 7. And that is okay. Now the other thing I could do is turn this into a 2, this into a 7, this into a 6, and this into a 4. So multiply everything by 2, and then that is balanced as well. So that is okay as well. It's entirely up to you which of those 2 scenarios you take. Okay? All right. Let's talk about our PCl5. PCl5 plus H2O. goes to POCl 3 plus HCl. Okay, now I'm going to erase some of my cheat sheet or balance sheets up here just because I've already used them and I don't need them. So I'm going to get rid of them so that I can work with the equations. All right. So I have a phosphorus, I have a chlorine, I have a hydrogen, and oxygen. I have to deal with all of those. I currently have 1 phosphorus on my reactant side, 5 chlorines on my reactant side, 2 hydrogens, and 1 oxygen. In my product side, I have 1 phosphorus, 1 oxygen, 4 chlorines, 3 plus 1 is 4, and 1 hydrogen. So I'm going to multiply this by 2, and I now have my 2 hydrogens. But I've now changed my chlorines as well. And look at that, I have 5 of them. Oh, did I do that? I did. I now have the same number of everything on both sides, and I'm done. Cool. I love it. Okay. All right. Scooching up a little bit. SC2O3 plus SO3 goes to SC2SO4 3. SCOS. That's what I got. Those are my components that are in it. I currently have 2 SC on my reaction side. I have 1 sulfur, and then I have 6 oxygens. I have 2 SC on my product side. I currently have 3 sulfur over here, and I have 4 times 3 is 12 oxygens over there. Okay. So my SCs are good. My S's aren't. So since I have 3 sulfurs here, what if I put this to 3? I would fix my S. Now I have 3 there. 3 times 3 is 9. Oh, that's 12. Snap! I'd be done. I love it. So remember to distribute the 3. It applies to both the 4 oxygens, so 3 times 4 is 12, and 3 times the S. Okay, so don't forget to distribute that. Cool with that. One more. Al plus H2SO4 goes to Al2SO4 3 plus H2. I have an Al, I have an H, I have an S, and I have an O. I have 1 Al, I have 2 H, I have 1 S, and 4 O's. Over here, I have 2 Al, 3 S, 12 O, and 2 H. Okay, that's a lot. So I'm going to put 2 out here, and that makes those. So I have 3 of those. What if I did a 3 here? If I do a 3 there, that means my sulfur's okay. I then have 6 hydrogens. And then I have 12 oxygens. Okay. That's okay, that's okay. This one is not, that one is. So I have 6 hydrogens on this side and 2 on this side. So if I multiply this by 3, then I'm good. Oh, snap! I got them all. Go awesome. Okay, so we do have some back and forth. Sometimes when I fix one thing, I haven't fixed everything, and I need to go back and look at that. Okay, so understand that it's important that we keep our sheet, or our little tally sheet up to date. When I change one and it affects something else, I need to change them all. Right? So those are my things that I would look at in terms of balance. Questions, comments, problems on our balance. Let me see what our next slide is. That is questions. So I'm going to stop here because I've got something I got to do in a couple of minutes. So I'm going to stop here. I will post this and then we will come back and do the rest of our lecture.